Okay, hello everyone. Today I'm going to actually discuss about the how to evaluate the blue and green water footprints and for alfalfa farming as a single scale study. I'm going to talk about the water footprint concept, my case study, water footprint calculation, yield calculation, result and conclusion. So, a brief introduction about the water footprint. Water footprint was developed in 2008, 2008, actually by Professor Hoekstra in University of Twente in Netherlands. And the interesting part of the water footprint is to it consider both environmental impact and the water resources consumption. So the water footprint components, as we can see, the uh, actually the blue water footprint goes to the water evaporate from the actually the irrigation water evaporated from the field. The green water footprint is the precipitation evaporated from the field, and the gray water footprint, the water we need to assimilate those low pollution from the field. So how actually to separate those actually, especially the water consumption part, which is the blue and the green water footprint. So the really easy concept to do that is the sum of the maximum difference of the evapotranspiration and effective precipitation for each period divided by yield. And for the green water footprint, sum of the minimum of the ET and the actually effective precipitation for each period divided by yield. And Um, here, why Utah's alfalfa is important all the time we are talking about it. Well, I went to some statistic to see what's going on here. So I understood that the Utah is the fourth actually main producer of alfalfa in the U.S. and it is the first one as amount of farms in the U.S. because I was really interested. That was really interesting because it means that a lot of small and medium farms all over the Utah, and they are irrigating by not the center pivot or something like that. It is mainly will line. And for this project, I just pick one of the actually place in the one of the one field in Tropic, Gulf County, Utah. And the actually cultivation was the alfalfa, and it was the center pivot and the pressurized uh, field. So in order to do that, I said that the main things we need to do that is ET and the effective precipitation. So I get the ET from the open ET in symbol one as we did that in the class, which is I think the all together, all of them together. So it is sensible to do that by that. And then for the effective precipitation, I did by the weather station near the farm. But I consider the, as we study in this class, effective precipitation has a lot of methods to do that. But here, as Dr. Torres recommended to consider effective precipitation equal to precipitation of the, because it's a good estimate in the Utah. So I got the actually the those data uh, daily based on daily evapotranspiration and the precipitation of the whole. Then I run actually I'm sorry. I run my this is the the 10 added to those one in order to convert it to the actually unit we wanted. And I'll also by those actually be and the only things remained was the yield, and the yield was important to how to measure that. I'm going to discuss about that. So in order to do that, I again actually run the IQ crop, as all of you knows, climate crop calendar based on the what exactly it is possible to put in it as actually real as possible. So, and here I actually the result of the my actually run the yield of the Um, those actually that farm was 4.3 tons per hectare. So by those, I actually run the that formula you I mentioned before. So by the my calculation actually told me that it is for the each ton of the production of the alfalfa, we need 862 cube meter fresh water or irrigate. Yeah. And or for the green one, it is around 108. It is that source comes from the irrigation part, that the second comes from the precipitation. So it means that 89% of the actually the water, 89% of the water comes from the irrigation part, only 11% goes to green. And here there's some actually conclusion on the case. Actually, one of the important ones, alfalfa, actually the blue water was 8 times larger than the green one. It means that irrigation is the main part. And another one was actually evapotranspiration in that specific site around, for example, 417 and the precipitation 1010. It is around 20% of it, but it is not all of them goes to the green water. It was 11. And the yield comparison with the national average, the national average for alfalfa in US is 5.1, but that farm was 4.3. It is actually increase our water footprint in a specific, that specific, because it is divided by yield. So it is overestimate of the real, US, if consider US as a standard and the whole US, and it is much higher than that. It's what expected. And here are some references. It is mainly based on my last actually work in the water footprints. Yeah, it is. And this is and the one Alfalfa what actually Nishal is working on that. And thanks for your attention. Yeah. Thank you.